We can get full information about any chemical reaction from its equation only after these points are taken care of. The first one is the element-wise atoms on both sides of equations should be equal. Second, the state of each chemical and the conditions of chemical reactions should also be mentioned. We know that when the element-wise atoms on both sides of any chemical equation are not equal, such chemical equation is known as unbalanced equation or skeletal chemical equation. We have to balance the chemical equations. But why? The answer of this is, for any chemical reaction to take place, it has to follow the law of conservation of mass, which explains that why the chemical equation or chemical reaction should be balanced. In this context, the law implies that the chemical reaction is nothing else but the rearrangement of atoms. Thus, in a closed system, during chemical reactions, atoms can neither be created nor destroyed, and hence the total number of atoms on reactant side should be equal to the total number of atoms on product side. In other words, without balancing, the chemical equation or reaction will neither be completed nor correct. Hence, we need to balance a skeletal chemical equation. Now, let us learn how to balance a chemical equation step by step. Let us take one example. When zinc reacts with sulfuric acid, it forms zinc sulfate plus hydrogen gas. Let us examine this chemical equation. For this, we have to make a table in which we have to create 3 columns: element, number of atoms on reactant side, and number of atoms on product side. In element column, we have to write the elements: zinc, sulfur, hydrogen and oxygen. And in rest of 2 columns, we have to write the number of atoms respectively. As the number of atoms of each element is same on both the sides of equation, it is a balanced chemical equation. Let us take a case of unbalanced equation and try to balance it. Fe plus H2O gives Fe3O4 plus H2. Let's balance this equation. Step 1. To balance a chemical equation, first draw boxes around each formula. Do not change anything inside the boxes while balancing the equation. Step 2. List the number of atoms of different elements present in the unbalanced equation in the table. Step 3. Select the compound that contains the maximum number of atoms, which can be on any side of the equation, that is, maybe reactant side or a product side. In the compound, select the element which has maximum number of atoms. Then multiply the element with lesser number of atoms with a number such that atom on both sides become equal. Accordingly, we select the compound Fe3O4 in the example, and then the element oxygen in it, which has maximum atoms. There are 4 oxygen atoms on right hand side and only 1 on the left hand side. So we will multiply the reactant side with 4 so that oxygen atoms on both sides become 4, that is equal. To equalize the number of atoms, it must be remembered that we cannot alter the formula of the compounds or elements involved in the reactions. For example, to balance oxygen atoms, we can put coefficient 4 as 4H2O and not as H2O4 or H2O whole 4. After multiplication, the equation becomes Fe plus 4H2O gives Fe3O4 plus H2. Now let's move ahead with step 4. Fe and hydrogen atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atom first. We can see that after first step of balancing, hydrogen atoms have become 8 on reactant side, while remains 2 on product side. So, to equalize the number of hydrogen atoms, multiply the right hand side molecule by 4. After this, the equation would be Fe plus 4H2O gives Fe3O4 plus 4H2. Now, step 5. Examine the above equation and pick up the remaining element, that is iron, which is not yet balanced. So, to equalize the number of iron atoms, multiply the left hand side molecule by 3. After this, the equation will become like this: 3Fe plus 4H2O gives Fe3O4 plus 4H2. Step 6. Finally, to check whether equations stand balanced or not, let us count the element-wise number of atoms on both the sides of the equation. 3Fe plus 4H2O gives Fe3O4 plus 4H2. So it will be observed that element-wise number of atoms on both the sides are equal, and hence we can say that this chemical equation is now balanced. This method of balancing chemical equations is called hit and trial method, as we make trials to balance the equation by using smallest whole number coefficient. Does this equation tell us anything about the physical state of each reactant and product? No. The information about the physical state of the chemicals is still missing in this equation. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formulae. The gaseous, liquid, aqueous, and solid states of the reactants and products are represented by the symbols small g, small l, aq, and small s respectively. The word aqueous is written if the reactant or product is present as a solution in water. After indicating the physical states by using respective symbols, the balance equation becomes like this. Note that symbol G with H2O on left hand side indicates that in this reaction, water is in the form of steam, not as liquid. Usually, physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above or below the arrow in the equation. For example, when CO reacts with H2, it required 340 atmospheric pressure, which is written on the above of arrow, and gives CH3OH. Similarly, during photosynthesis process, conditions are also mentioned on and above the arrow. So we have now learned how to write a complete chemical equation by balancing the atoms, which is necessary due to operation of law of conservation of mass, and indicating the physical states of the chemicals involved in that reaction. Test your understanding by balancing this one reaction by yourself. In our next video, we will see different types of chemical reactions.